Alright, hello everyone, welcome to this video. So in this video I will be showing you how to install and run YOLO on your system. So for that, head over to this link, YOLOv4-Darknet GitHub. So I'll be compiling this on Windows. So there are three methods for it. I had made a video earlier on how to compile on Windows using legacy way. They've removed this from this page. I guess it had a lot of errors due to version mismatches. So for this we'll be using the first method using CMake. Let's get started. So first we'll need Visual Studio Community Edition downloaded and installed on our system. Go to this link, download the Visual Studio installer, run it. Okay, once you're at this page, check this desktop development with C++ box. These are the things that we need right now. Click on install. This will install Visual Studio Community Edition to 2019 for you. I already have Visual Studio Community 2017, so I won't install this. But after it's installed, I'll go back to this page. The next software that we need is CMake graphical user interface. So go to this link and download CMake latest release for your platform. I have Windows. I'll download the installer for 64-bit. Once this is downloaded, click on it, just follow through this procedure. It's very simple. I already have it installed on my system, and the next step, download the Darknet zip archive with the latest commit and uncompress it. So download this file, extract it, this is the same zip file that we have over here. This one, download over here. Okay, go inside, copy this to the desktop or any location of your choice. Okay, so next in the Windows, okay, before we proceed further, I want you to install CUDA and cuDNN. So for that, just follow along. Type CUDA download. This is the latest version, but I want to download CUDA 11.0. I already have that one on my system. So go to archive, CUDA 11.0 update 1. I have this one. Click on this link, choose your platform, architecture, Windows 10, installer type local. This will download this for you. I'll cancel this. I already have these files in my download folder. Okay, so run this exe for CUDA. Okay, choose the extraction path, click on OK. Okay, now it's starting the CUDA installation setup for you. Okay, over here, just click on agree and continue. This is the recommended option for installation express. It installs all the CUDA components, so you just use this one. If you're using this custom method, make sure you have this Visual Studio integration checked. It's better to have this express installation method. Use this one, click on next. This will prepare your installation, and finally it will install CUDA on your system. I already have CUDA 11.0 installed, so I'll just stop it over here. Okay, once we have CUDA installed on our system, this is where CUDA will be installed in your program files in NVIDIA GPU Computing Toolkit, CUDA version 11.0. We have these files over here. Now just make sure, go and check your environment variables. When you install CUDA, it automatically adds these paths, CUDA path _v11_0, this path over here. So if you don't have these paths, make sure you add them to your system variables. You can add both CUDA path and CUDA path _v11_0. So okay, now next step that I want you to do is download cuDNN. I'm asking you to download this CUDA cuDNN so it works for your GPU, and that will make everything faster, object detection using YOLO or any other method. So just type cuDNN archive, go over to this link, download the latest version for your CUDA version, download cuDNN 8.0.5 for CUDA 11.0. Use your platform. I need cuDNN library for Windows. For this cuDNN to download, you will need to have an account on NVIDIA. Just log in. Okay, we're logged in. Now we can download this file. Okay, I already have this file in my downloads. Stop this. Go over to the downloads. Okay, so unzip it over here. Okay, so what I want you to do is copy all these 3 folders and paste them inside this CUDA v11.0 where your CUDA files are installed. Paste them over here. I have these files over here already. We basically want all these files in the bin folder. Over here in the bin folder we have these 7 files over here. Similarly, all the files in the include folder for cuDNN, there are 9 items. We need them here in the include folder inside CUDA. We have these 9 items here as well. And similarly for library x64, we need all these 14 items over here in library x64. You can see 14 items over here. So we've copied the cuDNN files over here. This is how we install CUDA and cuDNN. again we have to set another environment variable for cuDNN to point to all these cuDNN files that we just copied. We copied it inside the bin include library x64 folders. So add that to your system variables. Okay, now you move on to the next step. Close this. We have to download OpenCV. From over here, the latest version is OpenCV 4.5.1 right now when I'm making this video. So this is the latest. Download it for Windows. This will download the installer for you. Okay, so once it is downloaded, now click on the exe file. Choose the location where you want to extract your OpenCV to. I'll extract it inside my C drive. Extract it over here. Okay, so head over to your C drive, OpenCV. Now we have these files over here, the build files over here that we need. Now we have to give this path to the build files in our environment variables, system path variable, for a system to detect OpenCV. As you can see in my path, I have already given this OpenCV build and then OpenCV build x64 vc14 bin, and for library I have done the same for vc15. So let me show you what I did. Basically I've given the path to this. Over here we need these DLL files. I've given the path to this as well, and lastly I've given the path to both these locations as well. So let's go and do that. And after you've given these environment variable paths, you have to reboot your system. Okay, before I restart my system, I have installed this once on my system. So what I learned when I run darknet.exe, CMake GUI does not recognize my cuDNN directories, so it's unable to locate cuDNN unless we add another environment variable. We have to give all these three paths. We have to copy these and add them to the path variable in your system variables. Over here, these three where I copied my cuDNN files, just give these paths in your path environment variable for your system, and that is it. Click on OK, and restart your system. So I have rebooted my system. Now my system will recognize all my new environment variables. So okay, now we can start this steps mentioned on this page. Okay, in the Windows, click on Start button, all programs CMake, open the CMake GUI. Okay, so over here as is mentioned on this page, you can look at this image. What we need to do, first step, choose the source code and where we'll build the binaries, then click on configure, choose the Visual Studio version that you're using, choose the platform, click on finish and then generate, and then lastly you open the project. So that's what we'll do. Since I've downloaded the Darknet zip file and I have it on my desktop, so just select this folder, click on desktop, choose the source folder, then choose the destination where you want to create your binaries. Is the same path where you build your binaries. Okay, next click on configure, choose your version for Visual Studio, platform for generator x64, finish. This will configure the settings for your darknet.exe file. It will detect my CUDA compiler, CUDA 11. Okay, it has found my CUDA. So now my darknet.exe will be compatible with CUDA and cuDNN. Now what it says is my CMake CUDA architecture is 52. However, I know for my GPU NVIDIA 1070 it's 61. So I'll change this. I'll show you how. Just found the P threads in the darknet folder. Okay, that's fine. Found cuDNN, and it has also found OpenCV. It has recognized the path that we gave in the environment variable, and it has found our OpenCV. It's 4.5.1. So okay, everything looks good over here. Okay, so let me show you how we can find a CUDA architecture for our GPU. Go over to this page, developer.nvidia.com/CUDA GPUs. I'll give this link in the description. So just go down below and find your GPU. I have a GeForce GPU. So go over here, and I have GeForce GTX 1070. It's over here. As you can see, the compute capability, that is the CUDA architecture, for it is 6.1 and not 5.2 as was detected. This is the default CMake files have, so we have to change this. Go over here and change this to 61. Okay, that's fine. Enter. Now we'll see, since we have CUDA and cuDNN detected, it will have enable CUDA and enable cuDNN automatically checked, and it also has OpenCV checked, so we don't have to do anything over here. Okay, before I click on generate, just one thing. As you can read over here, please rebuild OpenCV from sources with CUDA support to enable it. There is a separate process for installing OpenCV DNN, so I'll be making a video on that for Windows and Ubuntu Linux separately, so that is a much longer process than this. This is just to get you started with darknet.exe. This will run it with GPU, but OpenCV DNN CUDA is much faster than that. Okay, so just make sure you check it out when I release those videos. Configure again. Click on generate. Generating done. Now we can open the project in Visual Studio. Okay, over here choose this x64, choose this release, and now you can simply click on build solution. But before that, go to configuration manager and take this for build for install, so that you don't have to run it again. Otherwise you have to run this for all build once and then for install the second time. If you do this, choose release x64, take this install over here and close, and just build it. It will just finish all these build and install processes and give you darknet.exe file. This takes a while, so just be patient. Okay, so as you can see, build has succeeded. We have no errors, so all 6 succeeded. Now if you go over to the darknet master folder, now we'll see we have darknet.exe file over here. Let's run this. Open up a command prompt over here. Let's try to run darknet.exe. Now in Windows, this gives you this error. Go over to this folder, third party pthreads, bin, copy this vc2.dll file, pthread vc2, and just put it alongside this darknet.exe, and now you'll see it will work. Okay, it gives us the usage, so it means it's working. Now let's try out a few commands for this. Okay, so let's get into it. Okay, so we can use the very basic commands for this, just to test our darknet.exe file. Now since we are on Windows, just change this to darknet.exe, detect cfg YOLOv4. We'll be using YOLOv4 for this, and then path to your image. We'll be running object detection on this image, and it saves the output as predictions.jpg. Let's run it. Before that, we need the YOLOv4.waits file. So we already have the YOLOv4.cfg file in this cfg folder. We have it over here. The YOLOv4 waits we have to download separately, so you can download from this link. I'll be giving this link in the description. You can also search for it on Google. You will find this link over here on this page, YOLOv4-Darknet GitHub page. Just enter this. This will download the waits file. Okay, so once it is downloaded, copy this and put it alongside this darknet.exe file. Okay, now we're good to go. Okay, so as you can see, it has detected my OpenCV, my CUDA version, my cuDNN, also my GPU count. It has detected my GPU, GeForce GTX 1070 with compute capability 6.1. Okay, it has detected all the objects in this image. Okay, the result looks good. Similarly, we can try it for another image in the data folder. Okay, this is also working fine. Now next, to run this YOLO on a video, let's go over to this website, pdready.com. So go down below. This is for a webcam. If you've seen my previous videos for Google Colab, the commands are the same. Now for a video, it should be like this. Change to darknet.exe, detector demo, path to your coco.data. This is for your pre-trained files for Coco. Coco has been pre-trained on 80 classes, so we need the data file for this. Then the YOLOv4 file for Coco, YOLOv4 waits, and then path to your video file. I'll copy this mask file over here in the darknet folder. Now since I'm not giving it my custom train weights and custom CFG, it won't detect the mask in it. It will detect the objects that are present in the COCO classes. It is trained on 80 objects as I told you earlier. So you can Google this COCO dataset online and read about this on this website as well, XCAB. So okay, I have given this mask.mp4, okay, and finally out file name and give it a name result.avi. This will save an output file with this name and run it. And this is working using your GPU. So as you can see, it is pretty quick. It will be a lot slower if you are using your CPU, which is why I asked you to install CUDA and cuDNN. So for the next video, you will know how to proceed. As I mentioned earlier, there is a separate way to install OpenCV DNN CUDA. As you will read over here, OpenCV is the fastest implementation of YOLOv4. This is OpenCV DNN. So I've given you an insight on how to install all these, so that will help in the future. Okay, the file has been written, so let's go ahead and check out the new file, video file. Okay, so the YOLOv4 weights have done their job. Okay, so now suppose I have to run it for a custom trained file. What I have to do, I will give it a path to obj.data, my YOLOv4 custom.cfg file, and my YOLOv4 custom underscore best.weights. These are the names of these files that I have. I have trained this on Google Colab, so I'll just copy these files over here. Okay, I have all these files over here on my desktop. I'll just put this weights file for my custom mask detection and I'll put it here in the same folder alongside darknet.exe, YOLOv4 custom underscore best.weights. That is the file name that I gave over here, and then obj data inside the data folder. Copy both these obj.names. Obj.names has the name of my classes, and obj data has these parts that I used to train. Copy these and put them inside the data folder. Okay, it's done. Lastly, copy this YOLOv4 custom.cfg file into the CFG folder. We already have one custom.cfg custom.cfg file, but that is not for, you can just replace it, replace the file in the destination. That is it. Now run this detector on the same video, and we'll see that it will be able to it will be able to detect mask this time. And as you can see, it is detecting mask in these images, in this video with the mask. So if you've seen my previous videos, I've shown you how to train a custom YOLOv4 detector using Google Colab. Now, since I've shown you how to install YOLO on your system, I'll be showing you how to train a custom YOLOv4 detector on your system. So make sure you subscribe to my channel and click on that bell icon so you get notified when I release my new videos. Okay, so it has saved this file, result mask.avi. Okay, so for the next step, to run it for your webcam, you can use the same command. Just remove the video files that you mentioned, the video file parameters. The rest of the command is same.
So okay, as you can see, this is detecting all these objects in this frame. Okay, let's close it. This is for camera. Now this will obviously depend on the speed of your GPU. Okay, let's close this.
Okay, so that is it for this video on how to install and run YOLOv4 on your system. I've shown you how to run YOLOv4 for your images, videos, and your webcam. If you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And alright, I'll see you in the next one.